Early Saturday morning at Palo Duro Canyon. It's just opened up. It's going to get real busy, but we got here just shortly after the park opened. Thank you to our guide and host, Scott Taylor. So a few words about the Triassic. We're here in the mid-continent, in the panhandle of Texas, and the light blue on this map is Triassic, and there is Triassic in the Basin and Range, and some in California, and some in the basins, rift basins in New York. But here, there is a real flat area. This is the Ogallala, is the yellow, and goes all the way up to the north. That's only Miocene, so it's very young. But the light blue here is the Triassic on the Permian, the red bed. So we're in red bed territory, and this little notch here, that little blue notch where the red arrow is, that is the incisement of the Palo Duro Canyon. And if you zoom in a little bit with a different color map, you can see the canyon. We're up in here looking down into this canyon, and it goes over 100 miles and fairly wide and about 800 feet deep. So this is a very significant canyon. And what's really cool is we're at the surface of the canyon, but below us in the subsurface, there's the Palo Duro Basin, and there are a couple uplifts, the Matador Arch to the south and the Amarillo Arch to the north. So we're about 25 miles south of Amarillo. But what's really interesting, we're going to see a lot of sedimentology, a lot of Triassic formations. We're going to go from the lower Triassic. There's a Permian at the base, there's a Paleosol, and we're going to see lower Triassic and upper Triassic. So this is all part of Gondwana. So when all the continents were together in the Permian before the breakup, this was a very flat area, and looking at the reconstructions, the winds would blow in from the Pacific Ocean, and the Ouachita Mountains, which is from the collision of Africa with North America, formed mountain ranges. So the moisture would come in and hit the Ouachitas. So there was no barrier to the moisture to come into the continent, but as it was raining down, we had a very flat continent, so there would be episodic and torrential rainfalls on a flat land. So there would be huge deluges that would produce standing waves in river and fluvial systems. So we're going to see, as we look at the various rocks and bed sets, we're going to see lots of evidence of high energy floods. And the basic stratigraphy is the quartermaster is at the base. There are these paleosols or geosols, this called the Spanish skirts. They're red and yellow, so that's at the unconformity. There's about a 30 million year gap, and we are into the lower Triassic, the Tecovas. The Trujillo is a series of sandstones, and that is the famous lighthouse, which is way off where we can't quite see it from here, but it's way off in the distance in the canyon. And on the very tippy top, let's see if we can find it, is the Ogallala Formation. So that is the Miocene Formation on top of the Triassic. So there's a major unconformity, but that Ogallala is a water aquifer, and it covers a large part of the prairie and mid-continent. So this is a real exciting opportunity to see some Triassic beds. They are at a time when Pangaea was together, one big major continent, and we're really looking forward to going down in the canyon. So our plan is we're going to do the CCC trail, we're going to walk down into the canyon, and then we're going to drive the park highway number 5, so we'll have many pull-offs and vistas, and we'll get a good look as we go down into the canyon. We're at the Ogallala. It looks slimy and it's full of bugs. Dissolution.
Exactly what I'm looking for. I'm looking for one of the large bugs. All right.
Not just these.
Are they fossils?
No, this is just erosion
And gypsum?
and as you look into the bugs,
Oh, here's one.
yeah,
Oh yeah.
that's what I'm looking
There
for
you
right
go.
there.
It's your extra.
If you look right up
more
here-
porosity.
That is actually opal.
Nice.
Oh. Is there iridescence?
Yeah, but it is a bug filling opal that has a botryoidal texture. Now there's your geology word.
The botryoidal
It's
texture.
fun to say, too.
Botryoidal.
Yeah, botryoidal.
Botryoidal.
Sounds like you're
Oh, boy.
from New Jersey.
botryoidal.
So that means it's botryoidal.
So this is opal,
Good.
and I'll try to. Can you point to where the opal is?
It's right there.
Right there. Okay. All right. And
Yeah, I got lucky when I broke that rocket. I got a piece.
Okay, so we're walking down the CCC trail. We're in the Ogallala. It's kind of a limestone with a lot of silica, and we're seeing botryoidal filled vugs. And the Ogallala is an aquifer, an important aquifer. There's a gravel bed in it, and we're just enjoying the beauty of the canyon.
Somewhere in there.
So point at the contact again there.
You use your
Yeah,
pointer.
the contact is going to be somewhere right in here.
That's the Triassic contact.
It's probably the Triassic contact.
Oh.
Ish. But we haven't seen the powder gravel yet.
That's what I was looking for.
This may be a paleosoil between them.
And so, how's it defined? Is there like fossils that define where the Triassic is, or is it
Yes,
lithology?
that's
Part of
partly.
your sea level dropping off,
Yeah.
and then rising all the way up, and then you get the shell and the mudstone.
And this is very much shale and mudstone, and it's a lot more organically rich than the
Yeah.
stuff up above.
Yeah. Bird?
An ash-throated flycatcher.
Where is he? Have you seen him?
Just heard him. He's kind of like a little machine gun. To the Cretaceous.
It either wasn't deposited or it was eroded off.
Which one?
Don't know. Nobody has been able to determine that.
Oh,
Say it's a little bit.
It's one of those things that who knows. We also don't have any Jurassic here.
so if there's no Jurassic and Cretaceous, it might have been a really big Paleo high. Because there's this Cretaceous seaway that just wants to cover everything.
Right.
Just on to the east of here.
But we have no Jurassic, we have no Cretaceous here.
I thought it was always eroded off.
We lose about 160 million years of geologic history between the Triassic and the Pliocene.
Wow.
And it either wasn't deposited in this area or it was eroded off from this area. And
Probably a little.
nobody has been able to determine which one of those it was.
But yeah.
And lots of people have tried, but there just doesn't seem to be any way to figure it out.
if there are any Cretaceous beds somewhere, Jurassic beds that are on lapping, or if there's any way to determine that, or whether they're just...
I don't know, but the Jurassic and the Cretaceous are missing from most of the high plains.
Must have been high.
It must have been high. That would be my guess.
Yeah.
So
there's the Park Road.
Yep.
We're taking the low road, right?
Last year they came and met us down in Big Bend, and this year they met
Just
us
take a look.
But so just the PGSD group was probably like 12 of us maybe. And then second and third day we were a big group. They had 2 big vans.
Oh, no, I love this. Okay. This is my kind of picture.
Great.
Now, this is my kind of picture here. I like the patterns.
Texture. You're a texture guy. Wait a minute. Let me
Now, this guy, the big filled bug that's broken open.
A bug that's broken open.
It's lined.
See, it kind of looks like a Triceratops is dying up there now.
Yeah, it does.
Oh, yeah.
In fact, I like that picture too.
Yeah.
Yeah.
I'll put this guy right
Nah,
here.
I don't want it.
Put it right
I got the piece of rock that I wanted.
here. You're going for the wood.
Hey, Scott. There. I'll swap places with you.
It kind of looks like a horse. Look at that.
It's going to turn into one of those.
Okay.
Where's Trujillo?
If you'll look over here, you see the Spanish skirt,
Yeah,
and you see where that yellow stops, where the
Yes.
limonite stops.
I see it.
That's the unconformity for the Trujillo.
So the massive sand up there is Trujillo?
No, it's Tecovas.
Tecovas. So the
Tecovas and
Trujillo is
Lower.
lower.
And the Trujillo sits on the quartermaster.
It's in the field guide he sent us, Charles.
Yeah,
Oh, that's all right.
I'm just kidding. I didn't
Don't have to worry about it.
I assumed so. I didn't open them either. I hadn't had a chance to yet.
Yeah, we're working our way down into it.
Two birds calling each other.
What is, I mean,
Prairie Dog Town Fork of the North Prairie Dog Town Fork of the Red River.
Red River.
okay.
It's Red River headwaters.
Yep.
Okay. I didn't know if it was actually still flowing.
Oh yeah.
Okay.
There's not much water
There's
in
not
it,
much yet.
but we'll see it later. See the grays and a little red.
trying to figure out, like,
A little red. See the gray bed, and then you come up and it's kind of a almost brown, and then you come up and there's a red bed right there at the top of it. That's paleosoil. And then just above that, there's another gray area, and then you see all of a sudden it changes to that kind of
Chalk.
tan.
My eyes are sort of seeing
red.
I'm seeing angles here, but I can't tell if it's just the way the rock's being eroded or if they're actually turned a bit.
No. Most of this lies
flat, right?
really flat.
So it's just the way it's eroding into
Yeah.
and that makes it look like it's
Right.
Okay.
And the other thing is that there's a good possibility that part of that is a big slump block.
Mm-hmm. That's what I see. Because like that big boulder there is kind of slumped
Yeah.
in, and so that makes sense that it's seen.
And as we get on around on the other side, you'll see huge masses of slump blocks. We'll walk right over the top of one.
Yeah, it's seeing something.
And you sit there and think,
Oh, I think right here too, you can see it slumping on this side. It almost
Right.
looks like a fault right there.
mm-hmm.
You got the
Because
Powder
And you
gravel.
got-
this
what's
is
that?
feldspars and quartz.
Mm-hmm.
This is mafics.
Mafics, yep.
Well, we don't have any of that here.
No.
Had to come from someplace else. So this is out of Colorado.
Got it.
Yep.
And this is part of the powder
And
gravel.
that gravel bed is where in the section?
It's above us somewhere, but it seems to be covered right here.
Yeah, that's what
So
you'll
it'd be
find.
above that limestone, but before the Paleosol
Yeah.
issues.
Yeah, so that's where those quartzites are all
Yeah,
coming
these
from.
and you know
So then that's the transition from the
That's-
base and the top.
Yeah,
Yeah.
that separates the Ogallala.
Okay.
yeah, the old Galala sits on top of the Triassic here. So, but yeah,
And that's the aquifer.
Keep an eye out.
Got it.
I know it. The Matrix.
you know, and
So we're working our way down the CCC trail, and we're looking at the various Triassic layers, and we have some really good river deposits up at the top, but there's some massive floods, thick bed deposits that were deluges deposited in really high flood regimes. One of the speculations is that there were some lakes that were breached, so kind of like Missoula. So in addition to torrential rains and storms and monsoons, there's really high water flows, and you can see the thick beds. And so up on the top of this ledge, it gets into a lot of thinner bedded as the energy declines, but you can really see the cross-cutting channels. So it's a sedimentologist's dream.
favorite part, Charles?
So we're exploring the bed forms and the sedimentology in the Dockham group, and we're just looking at some of the channels and cross bedding, and there's ripples and all kinds of different rapidly changing flow regimes from a sedimentological
It
standpoint.
looks like it. Have the dunes that are being cut out, so you actually get to see the dune forms. You know, in 3 dimensions. You don't normally get to see you get to see the tops or the edges, but you don't get to see the sides of them.
Gotcha. Yeah, so Linda,
Okay, we're gonna.
what we're talking about are dunes and anti-dunes. Okay, so we're looking at one of the large sedimentological features that was deposited in a high flow regime, a lot of flow. It's an anti-dune. It's a big package of sand, but on the sand there's a lot of layering as the energy waned, and over here there are some ripples.
Put your stick where the ripples are. Oh, okay, right there. Okay. Ripples.
Is because I want you to look at the rock. You'll notice that it is jointed this way and this way. These joints are prevalent in this formation. The interesting thing about the joints is that we know that the Prairie Dog Town Fork of the Red River cut through this rock, because when you walk over here, and the joints are very prominent. You can see the rectangular shape of the rocks. Now look at the river. The river follows the joint pattern that is up here. People keep asking how old the canyon is. Well, we think it's about 1 million years old. But the river down there cut through this rock and maintained the joint pattern. So if you look at it, it goes down and then makes a right turn, and then goes down a ways and then makes a left turn. And then it goes down a ways and makes another 90-degree turn all the way through that follows this joint pattern exactly.
So it started here.
The river came down through this
Through this,
and then cut all this stuff out.
Jointing?
Yep. Yes, it is.
What's the age of the jointing?
Don't know the jointing, but I suspect it's laramide.
Yeah, probably.
That would make sense.
And you were asking about big slump blocks? You can see one of the big slump blocks from right here. You see the red beds coming up? If you look just past those red beds, you'll see some big rocks sitting there. And if you look at the deposition of that entire area down there, it's all chaotic. Well, that is a giant slump block that reaches from here all the way to the base of the canyon.
So we're nearing the end of the CCC trail, and we're looking to the east, or excuse me, the west, and we've got the sun. It's in the morning, so everything's perfectly lit up, so we can really see the unconformity. The red beds at the base are the quartermaster of the Permian, and above it there is you can see that it's slightly angular, but there's yellow, black, red, white paleosols. And if you follow them around in the distance, you can see all through the canyon, and like most unconformities, there's a bunch of angularity. And as it comes over to this part of the canyon, you can see down here, there's some dip slopes where there's yellow, paleosols and black, but the very base of this incisement is down in the bottom where it's red is the quartermaster. So you can see that unconformity all on this side of the canyon, all on that side of the canyon. So we're really getting a look at the top of the Permian, base of the Triassic unconformity in Palo Duro Canyon. So this is a really nice example of a hoodoo, and the cap of this erosional tower is one of these Triassic sandstones. It looks like it's a cross-bedded sandstone that is weathering more resistant to the clays below it. And the dip is to the northwest, and our friend Scott pointed out that the tops of the hoodoos usually are a good way to tell the regional dip because they're still in place, and so it's dipping to the northwest. So the deposition of these Triassic units were dipping down to the northwest at time of deposition.
This big around and this tall.
I know, they're like hematite poop. Look at it, they're like on all this stuff. Yeah.
It's really fun.
And those
I know, too.
can form spherically too, right?
Sometimes they form hematite nodules.
Nodules, yeah.
So if you just, this is so one of the things is to sketch and to draw it out. You could draw out that unconformity. When it's you can trace it out.
Now,
do you see? Do you see it with your eyes?
Right here is upside down.
Look at the very bottom of the canyon. It's red. See the Permian red beds? It's all red, and then over on the side there's red, and right where there's gray and red and yellow, that's black and yellow and red. Those are the paleosols, so that's on top of the unconformity, and you can just trace the top of the Permian red beds all the way up in the, this is the eastern canyon, and back around, and then right here in on this side, and trace it all the way around.
And here's another piece of that chaotic bedding right here.
Watch your step.
This is great.
Yeah, no. There's some hematite zones right there that are sticking up. So that rock's upside down.
Between the Permian and the Triassic.